This is a solution to one of the practice problems for three cars moving, colliding in momentum. Three cars moving as shown below. In a miracle of timing, they all collide at the same time and stick together. How fast are they traveling after they stick together? So I've got three cars combined, as you can see in the picture. They hit each other, and then afterwards they stick together. So they move as one object. So here's my strategy. Every body has momentum. That's every object has momentum. So after the collision, the three cars move as one body. And here's how I'm going to solve it. I'm going to set up the sum of these momentums before the collision and after equal to each other. So before the collision, I have three bodies. I'll have three momentums. And after the collision, I'm essentially having one body. So I'll have one momentum. So I'm going to use the fact of conservation of momentum. Sum of all the momentum before the interaction equals sum of all the momentum after the interaction. I have three bodies, so I have three momentums. And you can kind of look and see where I got my subscripts from in my diagram. And afterwards, I have all three moving at the same velocity because they're moving as one object. So I set that up as shown on the right. Okay, I'll put in my numbers and my units. Notice that the 1,000 kilogram car is moving to the left while the other two cars are moving to the right. So the 1,000 kilogram car has a speed of negative 3 meters per second. Now I'm going to do a little bit of math. I'm going to divide everything by 100 just to make the numbers a little bit easier. And now I can do most of the math in my head. So 13 times 7 plus 11 times 5 plus 13 times negative 3. And that equals the sum of the masses, 13 plus 11 plus 10, times the velocity. So here we go, a little more work. And that sets up to 116 is equal to 34v. Divide both sides by 34. And that gives me my velocity. And it's 3.41 meters per second. Because it's a positive velocity, that means afterwards the three cars are moving in what I decided to be the positive direction. So for this problem, that was to the right.